Welcome back, students. So, we are in the third part of the chapter metals and non-metals. Today, we will define few terms and we'll see the entire metallurgical processes, how it takes place. So, let's begin. To understand the metallurgy, we have to understand few terms. The first such terms is minerals. So, what are minerals? The natural minerals contains metals in the free or combined states. So those materials which will contain metals in the free or combined state are called minerals. Next, we have to understand what is an ore. Ore is a mineral from which a metal can be profitably and conveniently extracted. This is very important to understand. Remember, all ores are minerals, but all minerals are not ores. Next, we have to understand the term metallurgy. The various processes involved in the extraction of metal from its ore and then refining them for use is called metallurgy. Say, for example, an ore can be just like a stone. From that stone, if you have to get aluminium out of it or the aluminium sheets out of it, it requires a series of steps. Those series of steps will be called metallurgy. Next term which we should understand is called gangue or matrix. The unwanted impurities such as sand, stones, mud, etc. associated with an ore is called gangue or matrix. So what are the various metallurgical processes? The 5 different steps. The first one is crushing and grinding of the ore. Number 2 is a concentration of the ore. I'll tell you what is concentration a little bit later. Third is conversion of the concentrated ore to metal oxides, either by calcination or roasting. So we'll come to that even later, calcination and roasting. Next, reduction of metal oxides to impure metal. And finally, refining of impure metal. As we go ahead with this particular slides, you'll understand this few terms better. Crushing and grinding of the ore, let me just tell you, we have a stone that mineral looks maybe, or the ore might look just like a rock or a stone. These has to be finely powdered. So for that, we need to crush and grind it. So that is what is your crushing and grinding of the ore. Anyway, as we proceed, you will understand this better. Let's go for the next part, that is called extraction of metals. If we remember the activity series, there are some metals such as potassium, sodium, calcium, magnesium and aluminium which are at the top of the activity series. These are highly reactive and they are never found in the free state. Again, if you go in the middle of it, there are metals such as zinc, iron, lead and tin. These are in the middle of the activity series and they are of moderate reactivity and they are not found in the free state, but they do exist in the Earth's crust as oxides, carbonates and sulfides. Again, if you look at the bottom of the reactivity series, there are metals such as copper, silver, platinum and gold. These metals are found in the free state in nature. Let's understand now what is concentration of the ore. The processes that help in removal of gangue particles from the dressed ore is called concentration of the ore. What are the gangue particles can be? These are earthly impurities such as sand, silica, mud, clay, etc. So all those, if we need a series of processes for doing it, those processes which we can use to remove the gangue particles from the ore is called concentration of the ore. Now, the methods of concentration which needs to be used depends upon two factors, and this is very important. It depends upon the nature of the ore and impurities present in the ore. If you get a question like this, on what basis does which method to be used for concentration of ore is decided? It is decided upon two factors. One is the nature of the ore, and second is the impurities present in the ore. Next, a question might come: name some methods of concentration of ore. There are normally three methods which we are going to discuss here. One is electromagnetic separation. Number two is gravity separation or hydraulic washing. And third one is froth flotation process. Let's understand what is electromagnetic separation. In this method, the pulverized ore, that is the powdered ore, is allowed to fall on a moving rubber whose one end is attached to a powerful electromagnet. The magnetic part and the non-magnetic part falls down to make a separate heap. This is natural. The ore particles which are magnetic in nature will fall near the magnet, but something which is non-magnetic will fall away from it, so making a separate heap. This method of concentration is used when either the ore is magnetic or when the gangue is magnetic. Next method is hydraulic washing. In this method, the pulverized ore is poured over a wide rocking table fitted with corrugated boards. The finely powdered ore is placed there, and a strong jet of water is passed through the ore. Now, the lighter gangue particles gets carried away by the water and gets removed, whereas the heavier ore particles remains behind. Now the question is, what type of ores are concentrated by hydraulic washing? The answer is oxide ores. And the example can be Fe2O3 or the hematite. Iron ore is an example by which iron is extracted, or let's say concentrated, by hydraulic washing. Another question can be asked: what is the condition for the ore to undergo hydraulic washing? Those ores where the gangue particles are lighter than the ore particles is concentrated by hydraulic washing. Next method is froth flotation process. This method is based on the principle that the ore is immersed in a mixture of water and oil, pine oil. The ore particles are wetted by oil, whereas the gangue particles are wetted by water. In this method, the gangue particles are heavier than the ore particles. In hydraulic washing, gangue particles are lighter than ore particles. In froth flotation, gangue particles are heavier than ore particles. This froth flotation process is used for sulfide ore. Now, what happens in this ore, in this process? In this method, sulfide ore is placed in a large tank containing a mixture of water and pine oil. A strong current of air is used to agitate the mixture such that froth is formed. The particles of ore stick to the oil, whereas the gangue particles settle at the bottom of the tank. The sulfide ore is then skimmed off, washed and dried, and that's what you get as a concentrated ore. Let's discuss with few metals or extraction of few metals. Say for example, extraction of mercury. Mercury is extracted from a cinnabar ore. If they ask you a question, name the ore of mercury, the answer should be cinnabar. And how it is extracted? It is extracted by heating the cinnabar ore strongly in the presence of air. So see the reaction of cinnabar ore. Cinnabar ore formula is HGS. It reacts with O2. It becomes HgO plus SO2. HgO further undergoes heat. On heating further, becomes mercury and gives out oxygen gas. Similarly, if you look at the extraction of copper, copper is extracted from copper 1 sulfide by heating sulfide ore strongly in the presence of air. The sulfide ore is Cu2s, again reacts with oxygen, O2 becomes Cu2O plus SO2. Cu2O reacts again with Cu2s to form Cu plus SO2. Now we have to understand three terms. One is calcination, second is roasting, and the third one is reduction. Calcination, the process of heating an ore in the absence of air, is called calcination. So what is roasting? The process of heating an ore in the presence of excess of air is called roasting. Whatever ore undergoes calcination, the answer is carbonate ore. Whatever ore undergoes roasting, the answer is sulfide ore. So if the question comes, differentiate between calcination and roasting, these two points you are supposed to write. Next, what do you understand by reduction? The conversion of metal oxide into metal is called reduction. Next comes smelting. Smelting basically is the reduction of metal oxides to metal, either by the help of coke or by carbon dioxide. So in this case, let us try to understand what happens. The oxide ore is mixed with coke and heated strongly to get impure metal. Now instead of coke, we can also use carbon monoxide gas to reduce the metal oxides to metal. Some examples has been shown, like CuO plus C gives you Cu plus CO. Zinc oxide plus carbon monoxide gives you zinc plus carbon CO2. Now any reaction can be asked in the exam. It can be Fe2O3 plus C. What will it be? Fe plus CO, you write it. If it is Fe2O3 plus CO, you write Fe plus CO2. So just take care of that. If there is only carbon, it becomes carbon monoxide. If carbon monoxide is given, it will become carbon dioxide. Next, reduction by highly reactive metals. This is important. Some metals such as sodium, potassium and aluminium, these are so reactive that they can be used as reducing agent. Now why they are used as reducing agent? Because they can easily displace metals of lower activity from their compounds. Example, when manganese can be extracted from manganese dioxide by using aluminium. So aluminium is more reactive than manganese, so it will become aluminium oxide and manganese metal is given out. Similarly, if you take Cr2O3, chromium from chromium oxide, take aluminium is more reactive than chromium, so it becomes chromium and aluminium oxide. Now, there is next question which can be asked is, what is a thermite reaction? In this reaction, a mixture of iron 3 oxide and aluminium is placed in a small earthen pot having a hole at the base. Then the cavity is made in the middle of the mixture and powder of magnesium and barium peroxide is placed. When the mixture of magnesium and barium peroxide is ignited, the reaction between iron 3 oxide and aluminium starts. And the reaction is highly exothermic, gives out a lot of amount of heat, and it forms molten iron. And aluminium oxide remains on top of it. Now the advantage of aluminium oxide being on top of it is that it prevents the rusting of iron. Now where this thermite reaction is used? It is used in two cases: to join cracked machine parts or to join broken railway tracks. Next, how the extraction of highly reactive metals such as sodium, potassium or aluminium takes place. Now oxides or chlorides of metals such as sodium, potassium or aluminium, which are at the top of the reactivity series, cannot be extracted by carbon reduction process. However, metals are obtained by electrolysis of their molten chlorides or oxides. Say for example, extraction of sodium. During the electrolysis of sodium from sodium chloride, in the exam sometimes the questions are asked, which one is the anode used? We should remember the anode in the case of extraction of sodium, that during the electrolysis of sodium, or for the extraction of sodium, the anode used is graphite. The cathode which is used is steel, and the electrolyte which is used is sodium chloride. And reaction of the cathode is what? Sodium gains one extra electron to become Na plus. Chlorine loses actually one electron and becomes Cl. So 2 chlorine adds up, becomes Cl2. Similarly, potassium metal can be extracted by the electrolysis as shown above. Now, important one is extraction of aluminium. So during the electrolysis of aluminium, which is the anode used? The anode will be graphite. Which is the cathode used? Again, graphite, carbon rods. But what is the electrolyte? Electrolyte, remember, is fused aluminium oxide. Now, aluminium oxide has got a very, very high melting point. So it is mixed with little bit amount of cryolite. When cryolite is added with aluminium oxide, it lowers the melting point of aluminium oxide so that the fusion or the melting of aluminum oxide becomes easier. Now, another question which is asked for this particular extraction is that why the anode has to be replaced periodically. If you see the reaction of the cathode, in the cathode aluminium is obtained as Al3 plus, accepts the 3 electron, becomes Al. But what about the anode? Anode, oxygen is formed or oxygen gas is formed. So carbon reacts with the oxygen gas to become CO2 or carbon dioxide. So that's the reason the graphite rods which is kept at the anode has to be replaced periodically. Next, when we go for refining of metals. So what is refining of metals? The process of purifying impure metals is called refining of metals. Now, electro-refining of metals means what? The process of purifying impure metals by electrolysis or by electrolytic process is called electro-refining. Now, what are the steps involved in the electro-refining of metals? There are 3 very crucial steps. First one, to the electrolyte, we need to add a small amount of acid. Now, why acid is added? It is added to make the electrolyte a better conductor of heat. Second, or electricity. Second one, anode is always the impure metal. Cathode is always the pure metal. On passing electric current, impure metal dissolves in the electrolyte, whereas pure metal gets deposited at the cathode. The impurities gets collected at the bottom of the anode and is known as anode mud. Now this is asked in the exam. What do you understand by anode mud? The impurities which gets collected at the bottom of the anode is known as anode mud. Now this question again is important. What are the advantages of electro-refining? The 2 advantages, you have to remember this. It produces metal of very high purity. Second, it helps in recovery of valuable metals such as gold and silver. Now in the electro-refining of copper, what is the cathode used? Always pure copper metal. Anode used? Impure copper metal. And what is the electrolyte? Copper sulfate solution. But it is acidified with sulfuric acid. Now during the smelting process, as we have discussed before, 2 things we have to mention. Remember, all the gangue doesn't get removed during the concentration process. Some amount of gangue still remains. Now this has to be removed during the process of reduction. Now how it is done? Gangue is mixed with a substance which is known as flux. So gangue plus flux gives you slag. Once again I'm repeating. Remember this. Gangue mixed with flux, F-L-U-X, flux, gives slag, S-L-A-G. So that slag gets removed during the process of reduction. Now, another part is that what is an alloy? An alloy is a homogeneous mixture of 2 or more metals or non-metals which are obtained by heating them together. Now, what are the alloys are needed? Alloys are needed for 4 reasons. One is to change in hardness. One example, if you see, pure iron or the pig iron is very soft. But when that iron is mixed with a little bit amount of carbon, it becomes steel, which is very hard. Same way, if alloying takes place, it can be resistance to corrosion. It can also change the melting point. In the case of solder, if you see soldering iron and all, the solder, it is a low melting point, so it changes the melting point. And finally, change in electrical conductivity. Now, so there are some common alloys, and you have to remember what are the constituent of it. One is stainless steel. If you see stainless steel, the main constituent will be iron, carbon, little bit amount of chromium, and nickel. These are the four main constituents of stainless steel. Brass, copper, and zinc. Bronze, copper, zinc, and tin. Gunmetal, copper, tin, zinc, and lead. German silver, copper, zinc, and nickel. Bell metal, copper and tin. Solder, tin and lead. Type metal, lead, tin, and antimony. What about 24 karat gold? Is it an alloy? No, it is a pure gold. But what about 22 karat gold? 22 karat gold means it contains 22 parts of pure gold and 2 parts of copper or silver. So thank you. Thank you so much for listening.